Hello everyone, welcome to this channel. I'm Payman Hassari. In this tutorial, I'm going to implement linear regression in KNIME using the housing dataset. The link to the dataset is in the description. Let's get started by creating a new KNIME workflow. Go to the file, click New, choose New KNIME workflow, and click Next, and giving it a name. And click Finish. And now let's bring the dataset into the canvas using CSV Reader node. Bring the node here and configure it. And locate where your dataset is. And open it. And click OK. And execute the node. And in order to take a look at the node, again, right-click and choose File Table. And this is the data set. We have 545 rows of data with 13 features. And here price is our target variable, and the other features will be used as predictors. Let's first see how many missing values exist in the data set using group by node. Bring the group by node here, connect it with this node, and configure this one. And go to the manual aggregation and select all the features and choose missing value count for all of them. Click OK and execute it. And in order to take a look at the result, again, right-click and click on Group Table. And as you see, there is no missing value in the dataset. So since there is no missing value in the dataset, the only pre-processing steps that I'm going to do is to convert the categorical variables that we have here into numerical and remove unwanted features and normalize the data, and then I will build my linear regression model. Let's convert the categorical variables into numerical using one-to-many nodes. Look for one-to-many nodes. Bring it here. Connect it with CSV Reader. And configure this one. All of the categorical features has been chosen, included. And we're going to remove the included columns. Click OK and execute. Let's take a look at the results. And now, as you see, there is no categorical features anymore. When we convert a categorical variable into numerical, the number of features that is being created for that categorical variables is the same as number of categories in that feature. For example, for air conditioning, there are two variables, yes and no, so two column has been created. For furnished status, we see that there are three categories: furnished, semi-furnished, and unfurnished. There are three new column has been created. And if you pay attention here, the sum of these three column is always equal 1. And this introduces multicollinearity in the dataset. And in order to get rid of multicollinearity, we need to remove one of these features. For example, unfurnished one for this case and no for this case. The same for the other features. And that is what I'm going to do next. So in order to get rid of those unwanted features, I use a node called column filter. Bring the node here, connect it with this one, and configure it. I'm going to remove all of the no features. And this one I will remove unfurnished feature. Click OK. Let's execute it. Now we have 14 columns. Next, I need to split the data into training set and test set using table partitioner node. Bring the table partitioner node here, connect it with column filter, and configure this one. The first partition type, I'm going to choose relative, and I use 75% of the data for training. And the sampling strategy, I'm going to choose random and using a fixed random seed in order to make sure that no matter how many times I run this process, I get the same training data set. Click OK, and the rest would be for testing data. Next, I'm going to normalize the training data set using normalizer. Bring the normalizer operator here and connect it with the first partition of this one and configure this one. Okay, I'm going to include all of the features that I have, and the normalization method, I'm going to choose z-score, which transforms the entire dataset into a new dataset where the mean of each column is equal 0 and the standard deviation of each column is equal 1. Click OK and execute. Now our data is ready. Next, I'm going to build linear regression model using linear regression learner node. Bring the linear regression learner node here, connect it with normalizer, and configure this one. The target variable is going to be price, and I'm going to use the entire features that I have and click OK and execute the model. Now my model is being built. Next, I'm going to apply this model on the training set and calculate the performance of the model on the training set using regression predictor. Bring the regression predictor node here. It has two inputs. One is the model that comes from the linear regression model, and the other one is data that comes from the normalizer. Configure it. Basically, it has nothing to configure, and execute. And if we take a look at the result, now I have the prediction of each house along with their price. This is the actual price, this is the prediction. Next, I'm going to calculate the performance of the model using numeric scorer node. Bring the numeric scorer node here, connect it with this one, and configure it. The reference column is gonna be price, and the predicted column is gonna be prediction of price, and leave the rest as it is and click OK, and execute and open views. And we see that, for example, R squared now is 68.5%. So this is the performance of the model on the training set. Next, I'm going to calculate the performance of the model on the test set. In order to calculate the performance of the model on the test set, first I need to normalize the test data using the same normalizer that we use for training. So I need to apply this normalizer on the test data. And in order to do that, I use a node called normalizer. Bring the normalizer, apply here. And it has two input. One is the model that comes from the normalizer, and the other one is the data that comes from the second partition of the table partitioner. And configure it. Again, it has nothing to configure. Click OK and execute. Next, bring the regression predictor. Here. And it has two inputs. One is the model that comes from the regression learner, and the other one is data that comes from the normalizer apply, which is the test data. And configure this one. Again, it has nothing to configure, and execute. And finally, in order to calculate the performance, use the numeric scorer one more time. Bring the node here, connect it with this one, and configure. Again, reference column is going to be price. Predicted column is going to be prediction of the price, and click OK. And execute. And now we have 65.3% R squared for the test data. So now we have the performance of the model on the both training set and test set. And in order to improve the performance of the model, we can change the hyperparameter of the linear regression. We can change the way that we normalize the data. We can change the partitioning that we did on the data. And also we can change the way that we convert the categorical variables into numerical. Those techniques can improve the performance of the model